Okay, we have a gas supply that is connected to a manometer as shown. So the pressure of the gas here is equivalent to the pressure of this column of water plus the atmospheric pressure. Okay, so now we replace the water with mercury. So now let's look at the formula for pressure of liquid. Pressure is equal to the height multiplied by the density multiplied by the gravitational field strength. So mercury has a density that is much higher than the density of water. So to bring about the same amount of pressure here, the mercury column, it should be much lesser than the water column. So if we look at the option here, the answer should be C, where the mercury column above this horizontal dotted line is much shorter. So the answer is C. Okay, this is a hydraulic system. So the pressure on this side is the same as the pressure on this side. Okay, so pressure on this side can be calculated by the force divided by the area. Okay, so now let's write down an equation. So 80 divided by 40 is equal to the force on piston L divided by 2. So we'll get 40F is equal to 160. So F is equal to 160 divided by 40. So it's equal to 4 Newton. Answer B. Which is a property of both liquids and gases? They always fill their containers. This is not true for liquid. They are incompressible. It's not true also because gases can be compressed. They can flow. Okay, liquid and gases, they are called fluid because they can flow. So this is the correct answer. And option D, they have molecules in fixed position. This is wrong because only solid has got molecules in fixed positions. This is a question on Brownian motion. So from the microscope, you can see that there are bright specks of light that are moving in random motion. So these bright specks of light, they are actually the smoke particles. And why are they moving in random motion? Because they are constantly collided by the air molecules. And since the air molecules are moving in random order, they will collide with the smoke particles, and the smoke particles will go in random zigzag manner, just like what is shown here. So the answer is A. Okay, in a mercury in-glass thermometer, the volume will change depending on the temperature. So as the volume changes, it will affect the density. So density is not constant. The internal energy of the mercury, as the mercury gets hotter, there will be an increase in the kinetic energy. And since internal energy is the sum of total kinetic energy and potential energy, this internal energy will increase. So it's not the answer. The mass of the mercury will stay constant because mass cannot be changed in this case. And the volume of the mercury can change. So the answer is C.